Now, another OOP concept or mechanism is called overloading. Overloading is when a certain class, like for example dog, has two or more methods with the same name, say for example it, and the same return type but different argument pattern. Say for example, we will have another it method here. So we have public void it, but this time the second it method has an argument. Say maybe it has one argument string s. So this it method here is not the same as the it method here because they don't have the same argument pattern. The first it method has 0 argument while the second it method has 1 argument s of type string. So say for example, the implementation of the second it method is it's dog food and plus s. So in addition to dog food, it also eats something like s. So let's try to check in here now. What are the fields and methods of a class type dog? So let's say d dot. Take note that d, an instance of dog class, has now two methods, the it without arguments and the it with one argument. Because dog class, where d is an instance of that dog class, has two methods of the same name but different argument pattern, we can say that we are employing in here overloading. Okay? So overloading is an OOP concept or OOP programming mechanism where a class has two or more methods of the same name. Like in this case, the method name of the first method is it and the second method is also it. They have the same method name and same return type. But these two have different argument patterns. So again, overloading is an OOP mechanism or OOP concept wherein a class like dog has two or more methods of the same method name, like these two, it, and this is also it, and same return type, void, void, but these have different argument patterns. This has 0 argument, this has 1 argument. Okay, we call this argument pattern. Again, argument pattern refers to number 1, the number of arguments, how many arguments are there. Second, the data types of the arguments. And third, the order of the arguments. Okay, so this 3 specifies a unique argument pattern. So why do we think that this argument pattern of the first method it and the argument pattern of the second method it are not the same? Why are they not the same? This argument pattern and this argument pattern. Why? Because first, they don't have the same number of arguments. This has 0 argument while this has 1 argument. So on this item, they are not the same. Okay, say for example, they have the same number of arguments. Say for example, this is int x. So it here has 1 argument. It here has also 1 argument. So they have the same number of arguments, but for the second item, the data types of the arguments are not the same. This argument here is type string. The argument here is type integer. They don't have the same data types. Okay? What if they have the same number of arguments and the same data types of arguments? Say, for example, this is string also. It has string s. And this has int y. Okay, now compare these two argument patterns for the first it method and the second it method. They have the same number of arguments, 1, 2. This is also 1, 2. The data types are the same. It has a string type and integer type. It has a string type here and integer type. But on the third item, the order of the arguments are not the same. Okay? The first argument is integer type. The first argument here is string type. The second argument is string type. Here, the second argument is integer type. So, the order of the arguments is not the same. Okay, the string type is on the second argument, while the string type here is the first argument. The integer type is first argument here, while in here, the integer type argument is the second argument. So the order is not the same. Therefore, these two argument patterns are not the same. And so we can say that this it method and this it method here are not the same. They may have the same return type void, they may have the same method name, but they do not have the same argument pattern. And remember, for argument pattern, we are to consider these three items: the number of arguments, the data types of the arguments, and the order of the arguments basing on the data type of the arguments. So let's say we restore this back to the original 0 argument, and this is 1 argument. We save this, and then let's go back to test animal. And if we check it here, we have the two methods, it with 0 argument and it with 1 argument. So say we're going to run this or execute this, and for S, we are going to pass, aside from dog food, dog would eat human food, right? It's a string type. Therefore, we are to pass a string value. So we would say here, human food. Save this and run. So the first it method, this is the implementation, eats dog food twice a day inside the house. The second and third are the same from the animal parent class, and guard is the same. And the second it is eats dog food and human food. Okay, this one, which we pass as S in here. Okay, so it is displayed here. Eats dog food and human food twice a day inside the house. So whatever is the string value of S, which we pass here, that is the one that will be displayed in here. So the output is here, human food. That's basically the concept of inheritance. This is when we use the keyword extends, we are employing inheritance, and employing extension when we define a new method which is proprietary or unique to that subclass or child class. Overriding is when we change or redefine the implementation of an inherited method like this one. We change it into this implementation. From this implementation, we change it to this implementation. And overloading is when a class has two or more methods having the same method name, like in this case, this is it and this is it also, and same return type, this is void and this is void, but they have different argument patterns. This is not the same argument pattern as this one. So these two are not the same, and these two are found in dog class. So any instance of dog class type like D will have these two methods, the one with no argument and the one with one argument. So in our example, animal is the parent or the super class, and dog is the sub or child class. Animal is the parent or the super class. The access modifier, and then followed by the keyword class, and then followed by the name of the child or subclass, and then the keyword extends, and then the name of the parent or the super class. So this is how we employ inheritance. And to employ extension, we simply add a proprietary method or field or unique method or field to this subclass or the child class. And then to employ overriding, we simply change or redefine the implementation of the inherited method. Take note that this is inherited method because this is exactly the same as that, okay, the inherited method. But we redefine or we change the implementation. This is the implementation part and we change it to this. And for overloading, it is when two or more, in this case we have two, the first method void it and the second method void it with different argument pattern. So since this class dog has two methods of the same method name, it, and the same return type, void, but different argument pattern, this is 0 argument, this is 1 argument, then we can say that this class employs overloading. Now, what is the advantage of employing inheritance? One of the advantages is that if you're going to edit, whether you add new features, meaning fields or methods, or delete existing features or fields and methods, whether you add new features or delete existing features, whatever you do in the parent or superclass, the subclass, not just one, but all subclasses or child classes will be affected. Okay, so say for example, if we're going to delete play, then any instance of type dog will not also have this one. Okay, so this play method will be removed not just from the parent or superclass but also from all the subclasses. If you add new field or method, say for example, you're going to add a new method sound, then you would implement it as system out that println makes unique sound. So when you add this new method to this parent or superclass animal, automatically all subclasses will have this new method in them. So when you say d dot, you can see this newly added method. All subclasses will automatically be affected. So whatever you add in here or delete from here, all the subclasses will be added also with all of those features or will be deleted with all those features. So that would mean easy maintenance or easy modification of the subclasses. Okay, you don't have to do it individually. You change dog, you change all the other subclasses. All you have to do is change the parent class and all the subclasses will be changed also. So say let's go back to this parent class. Say we're going to add here a new method, public void sound. And then the implementation would say makes unique sound. So this is newly added, new method added to the parent or super class. So let's check here if D has it also. Say D dot, and there we have sound method which is inherited from the animal class. Let's save this and run. Okay, so this is now the execution of the implementation of this new method sound that we add to animal and which dog automatically inherits. Say this time we're going to delete a method from the parent or superclass. Say we delete play. Save it. And let's check. Okay, so take note that we get here an error which says that the method play is undefined for the type dog. So meaning the class type dog does not have a play method. Okay, so take note this is by inheritance coming from the parent or superclass animal. So let's check if, let's comment this out. Let's check this time d dot if we have the play method under dog class type. So take note that we have no play method anymore because it is deleted from the parent class and therefore the child class does not have that also. So looking back at the syntax to employ inheritance, after the keyword class, you specify the child class or subclass name and followed by the keyword extends and followed by the parent class or superclass name. So like in our case, we say class dog extends animal. And then open curly and close curly. And in here, you write all of those fields and methods which are proprietary to this new class or to the subclass or the child class. Like the example we have for dog, it is guard. So this method is unique to dog and it is not found in the parent class animal. So take note that the fields and methods that are defined in the parent class, like in our example, animal, it can be used without explicitly encoding them in the child class in dog. So what we encode here when we define the child or subclass dog are only those proprietary methods and fields. Second, class inheritance is a monolithic inheritance. When we say monolithic inheritance, it means that a child class or a subclass can only have one parent class. Cannot be more than one. So a child or subclass will always have only one parent class. That is the meaning of monolithic inheritance. Mono means one. The child or subclass inherits from only one parent class, not two or more. Only one parent class can be defined, and all classes inherit those from Java that lang. Let's compare this time the multiple inheritance and monolithic inheritance. As mentioned earlier, what is allowed is only the monolithic inheritance. Direct multiple inheritance is not possible in Java. Now, the concept of multiple inheritance is that a new class can inherit from more than one parent at the same time. Like for example, track is the child or subclass, and we want this child or subclass track to inherit all of the features of this one. The first parent P1 is car and the second parent P2 is crane. What happens here is that we want this child or subclass track to inherit from car and from crane. So we want two parents at the same time. So we want the track will inherit all the features of car and all the features of crane. But this is not possible. It is not allowed. Okay, so multiple inheritance of classes which is inheriting from more than one parent at the same time is not allowed. For example, this is parent 1, this is parent 2, and this is parent 3. And this is the new class we want to define. We want this new class to inherit from all these three parents. We want this new class to possess all the features of parent 1, parent 2, parent 3. Say for example, this is child C1 and this is P1, P2, and P3. We want to define C1 this way. Class C1 extends P1, P2, P3, and then open and close curly. But again, this is not possible. The syntax in Java allows only to specify in here one parent class only. Okay? We are not allowed to specify multiple parents, only one parent, and therefore we are allowed to do only monolithic inheritance, and we are not allowed to do multiple inheritance. As mentioned earlier, multiple inheritance is not allowed. When we say multiple inheritance, we mean that we want a child class to inherit from more than one parent, say 2 or 3 parents, at the same time. That is not possible. That is not allowed. We could still allow multiple inheritance, but it is done in a monolithic inheritance way, which means that a child class is able to inherit multiple classes by tandem monolithic inheritance. So this is the term we use for multiple inheritance by monolithic inheritance on separate occasions or at different times, not at the same time. Say for example, the first class we define is animal. We call this the parent class. And then the second class we define, which is the child class of this parent class animal, is mammal. We define human, which is the grandchild class of animals. So between mammal and animal, it is monolithic inheritance. Between mammal and human, this is also monolithic inheritance. So say for example, these are the features of animal. Say it has feature A, B, C. Say for example, A is a field, B is a field, C is a method, and D is also a method. Say these are the features or the fields and the methods of the class animal. And then we create mammal as a child class of animal. So we define mammal this way: class mammal extends animal. And say for example, we employ extension. Say mammal has proprietary methods such as fields E, F, method G, and method H. Okay, so these are the unique features of mammal. So all in all, mammal has all of these features. It has field A, B, and methods C, and methods D, and fields E, fields F, and method G, and method H. So these are all the features of mammal, which is a subclass or child class of animal. A, B, C, and D are inherited by mammal from animal, while E, F, G, H are its own unique or proprietary fields and methods. So mammal possess all of these features. And then when we create a new class, human, we say class human extends mammal. So by inheritance, human possess or inherits all the features of mammal. So all of this from A to H. And if human has some proprietary methods and fields, say for example, we have here fields I, J, and then we have methods K, and then L, and then M. Okay, so say these are the proprietary methods and fields of the new class human. So all in all, human has how many features? Human inherits from mammal all of this. So it has A, B, methods C, methods D, fields E, F, methods G, method H. So all of these are inherited from mammal, in which A, B, C, and D are actually coming originally from animal, right? So by tandem monolithic inheritance, we are like allowing a new class like human to inherit from two parents. Parent 1 is animal and parent 2 is mammal. So it's like human inherits from two parents, animal and mammal, but it is not inheriting directly from the two. It is inheriting indirectly from the two via monolithic inheritance. So all the features of animal were inherited by mammal, and all the features of mammal were inherited by humans. So all those features of animal were inherited by human through mammal. So the direct inheritance is not allowed, but the tandem monolithic inheritance is allowed. So multiple inheritance is still done, but not directly. It is done indirectly using the technique tandem monolithic inheritance.